In part 4 of this course on modeling a 4-stroke RC plane engine, we will construct the bearing housing assembly, which includes the bearing housing, large bearing, small bearing, and 4 screws. Once modeled, we will assemble everything using the correct type of joints. Welcome to the Learn It channel. Let's make the bearing housing assembly. So in this tutorial, we are going to tackle the bearing housing assembly. So if I isolate this, you can see we have 4 screws. We've got the bearing housing and we've got a front bearing and a rear bearing right there. So just before we get started, let's talk about a couple quick reminders. In the description below, you can find a link where you can download the plan book for this entire engine. And the second reminder is this entire series is also produced for absolute beginners as well. So if you're interested, those videos are for members only, whether YouTube or Patreon members. So hopefully you check that out. So let's get started. And here's where we finished off with our last tutorial. So let's go right into it. We're going to start a new component. And of course, this is going to become a sub-assembly. And we're going to call this our bearing housing assembly. Within our bearing housing assembly, I can just expand the browser there. We can create another new component, and this is going to be our bearing housing. Now from there, we can right click and we can isolate. And let's just get to sketching. So the first thing we're going to do is create a sketch. And of course, there's a number of different ways that we can do this, but this is just approaching one way. We are going to start off with the center rectangle, and I'm going to do the exact same thing here as our crankcase. So we're going to, first of all, constrain it vertically like this. And then we're just going to constrain it with dimensions as well. So the first one over here, 0.656. And to the top over here, we're going to go to 7.76 right there. Now I'm also going to create a reference over here. So let's create a driven dimension. And this is going to be just the same as we see on our drawing, 1.416. And then down here, I'm going to do almost the same thing, 1.34. But I'd also like to create just a couple references as well as we see on our drawing. 0.67 create driven, and over here 0.67. Again, this is just to verify that what I have on the drawing and what I've just sketched is accurate. And don't forget to print out this plan book, follow along with each drawing, and check off every dimension that you input. So we're going to start off with this primitive only, and then we're going to add all the fine features later. So let's extrude this. We can just start typing in our value right here, 0.094. There we go. Now, next, what we can do is we can create a sketch right on this face. We could also just right click and go create sketch. We've got our origin right in the center of our bore. So that was one reason why we created our center rectangle the way we did. And I'm going to create this a little bit different than our beginners tutorial. So if you've seen that, you'll see a different way that I've done it here. And this is quite easy. We're just going to put in our shaft dimension right there. And we can go right to extrude. We can pull this out and we're going to go right to our value 0.856. Now there is actually a chamfer over here. And usually what I like to recommend is that we save our chamfers to the very end. And so we're not going to put this in, but in reality, the manufacturing process of this bearing housing is it's a lot easier on a lathe to put on a chamfer, so to speak, in where a fillet should be actually. And the reason why they do this is because it's, again, a whole lot easier to turn this on a lathe rather than putting in a big fillet. But we're hopefully going to machine this out on a CNC machine, and a fillet, in my opinion, looks a lot better. So we can make that whole feature a whole lot better later on. So let's do all of our external cylinders first. I'm going to create another sketch on the other side over here, and we can just go right to town. There we go. And I'd like to position these off to the side, just like so. Finish that. And now let's extrude both of these here. 0.17. And then we can go back to our sketch, make sure it's visible. And we can extrude by long clicking. We can pick that profile on the inside and we can extrude it. Now here, the start profile plane, we can actually pick an object. We can pick that face and then we can bring this on out, and this will be the actual dimension on our drawing. So 0.08, we can hide that sketch. Now, as we've talked about before, getting into good organization habits, we can rename our sketches. There we go. Now let's put in all our bores as well. So we're going to take a look at this front long shaft side first. And what I'd like to do is quickly add some parameters to this because I've actually already produced the beginner's tutorial. I know that these bearings are not easy to find. So I'd like to create some parameters so that we can easily and quickly adjust this if need be in the future to suit whatever bearing size we find and import. So let's do this. And I'm going to create our first parameter is going to be our bearing housing large bearing diameter and then depth. And I'll repeat that with the small bearing as well. And we can just type in 22 millimeters just like that. Let's expand this so we can see it a little bit better. And now we can put in the depth as well. And then we'll repeat this with the small bearing. Now we've got all these parameters. We can just easily apply them to our model right now. So let's do that. I'm going to create a sketch right on that face and then just create a point as well. And that can be our point of reference. Even though it should default to the origin, I find sometimes in Fusion it doesn't do that. So let's go to our hole command and we can change this to counter bore and change all of our parameters. Make sure to include our parameter right here. And this is going to be our small bearing diameter right there. And our depth is going to be right here. There we go. And we can change this to our right dimension, 0.5, and then go all the way through. There we go. So that will reference our first bearing, and then we can do the same thing on the other side. Over here though, I'd like to create a sketch, and we can put in our diameters. That's going to be our first parameter right there. And then we can add the relief over here at 0.75. Great, finish sketch, and we can do the same thing as when we extruded this. We can settle that into our proper depth, which this is actually going to be minus, and then our large bearing depth right there, 7 millimeters. Excellent. Let's make that sketch active, and we can extrude this. Not that profile, but this one. And we can do the same thing. Let's do an offset. Start right there and we'll go the opposite way, and this is going to be our 16 thou dimension right there. So we have a little bit of an offset. At this point, make sure to rename your sketches. Next, let's add the holes. And so I'm going to create a sketch right on that face right there. And again, our origin is set perfectly. We can go to center rectangle. I'm going to go and select the construction line type. There we go. And let's just put in our dimensions as we see, and this will reference the center points for our drilled holes very quickly and easily. So let's just do that 1.031 there, and we'll do the same thing on the other side. We can also put in our reference dimensions right here as well. We can create driven, and as we see on our drawing, this is 0.516, but if we hover for a long time over it, it shows that it's actually indeed half of this value. But again, this is proving that our sketching is correct. Let's finish our sketch there, and we can simply put in our holes at this point. So we'll go to the hole tool and we'll pick all 4 of these. Now there is an error right here. If we go to clearance and pick the corresponding clearance size of the screw that we're going to use, you'll see that the dimension is slightly different. So I'm going to go on over here to unified screws. Go to the first one, it doesn't have a number 5 screw. So I have to go to the second set, and there is a number 5. We can go all the way through, and you can see that the diameter that it's finding here or selecting for us is 0.136. And on our drawing, it actually says 0.126. That is far too close to the diameter of our screw. And so I'd much rather go with this clearance diameter right here. I think on our drawing, it's probably just a mistake of the draftsman, or maybe they'd like it very tight, but regardless, I'm going to go with this method instead. At this point, we can add all our chamfers. So I can pick those 2 edges right there, and we're going to call this 0.11. Now I'm going to add a selection set, and I'm going to put one right here as well. And this value isn't actually on our drawing, so I'm just going to specify something, maybe 0.15. That looks about right. And then what I can also do is let's fillet those as well. I can do something like, oh, that's way too big, maybe 25 thou, something like that, maybe 50 thou, make them a little bit bigger. And this will add a lot more strength. Remember, in manufacturing, the sharper the intersection points, well, the easier it is to break or shear at that point as well. So There we have it. This is looking great. I'm going to save this so that we don't lose our work. And let's rename the sketch as well. I can just put in our hole positions. Now our bearing housing is done. We can adjust all of the materials later on. So now what shall we do? Well, let's add our bearing. So if we go to Insert, Insert McMaster Car Component, and we can just type in bearings. There we go. I'm going to make this a little bit bigger. Let's go to ball bearings. And we're going to go to permanently lubricated, and we're going to add bearing number 2 on the drawing. So on the ISO view, that is the bottom right bearing. And what we can do is we can search by OD. So let's find that, and this is a 22 millimeter OD. There we go. We'd like a sealed bearing, and the shaft diameter is going to be 8 millimeters, and the width is 7. So this is perfect. We're going to go right there. Make sure, actually, we haven't selected the right. We have to select this one first. Make sure we activate the sub-assembly, or otherwise, if we were to import a bearing, it would import it right into the bearing housing component right here and create a sub-assembly within that. So let's go, make sure that's active, Insert McMaster Car, do the same thing. And make sure we pick 2D or 3D step and go download. Very good, let's go OK, and then we can just drag this out right there. Let's join it to this face, to the center position, and then grab that corresponding face right there, and this will line up perfectly with that face. So this is looking really, really good. So let's do the same thing with our other bearing over here. So if we go to Insert, Insert McMaster Car, do the exact same thing. Now here we're going to sort it by shaft diameter. So if we go to 7 millimeters, you can see that we actually don't have an 18 millimeter bearing that we can select. We have a 19, 14, and 17. If we select 19, this might make the wall thickness too small or not beefy enough for our bearing to be press fit into that. It might make the material too weak. So instead of selecting 19 millimeter, I'm going to select 17, and let's import this. There we go. Let's go OK. And you can see because we've activated our subassembly right here, it's actually put these two bearings exactly where they need to be. Now here's a situation where our component is hidden by another component. We can just simply select that, and then we can drag it off to the side just like that. Let's do the same thing. We can pick that face and the center point, and pick this and the center point. And I think that's too far in, so we're going to go back right there. Let's go cancel, something weird is happening, so we can do it one more time. Pick those two and this face and the center point. And you can see now we've got a little bit of an issue. Maybe I made a mistake before, but let's go back to our parameters and we can simply change this now. So this is the small bearing diameter, and this is going to be 17 millimeters now. Perfect, that will be just like that. And apparently I have the wrong calculation. So 7 millimeters, if we're ever confused, we can just go right back to this part number, copy that, go Insert, Insert McMaster Car, search by that number, and it will bring it up right here. There we go. So this is actually only 5 millimeters deep. So we can pick that. I guess I could have picked a better one, but this is fine. Let's just stick with this. We can go 5 millimeters. There we go, and that will position it properly right there. So I think everything is looking really good. Now all we need to do is insert our screws as well. So let's keep our bearing housing assembly activated, and we can go Insert, and let's go to McMaster Car Component again. We can go Screws and Bolts. I will expand this for everyone's sake. Socket head screws, and I would like to go down here and actually use Torx Plus. Very good. Make sure it's a 540, and we're going to go 3/8 inch depth. Let's pick this and download that. Perfect. We can just move this right on out of the way. Excellent. And now let's join it together. I'm going to pick the face right there, and then I would like to position it what I would call quadrant 1. So if we're looking at the front face right now, I've taught this in many other tutorials that this would actually be quadrant 1 based off of our origin, and I would apply the other components or join them in the same order. So quadrant 2, quadrant 3, quadrant 4, and I'll show you in a moment why that actually makes sense and helps us. So now that we've got this screw right there, we can go to Duplicate with Joints, select our component, select our screw, and then we can just pick our other points of reference for our other screws. And we've got 1, 2, 3, 4, just like that. This is looking great. So now let's just do a little housekeeping. We can go to joints over here, and I've forgotten what these joints are. So let's go edit and see what these actually refer to. So this is the bearing to the bearing housing. So I'm going to go over here to this one. I am going to copy that number and then go to our joint and say this to bearing housing. And then we can hide that. I'll do the same thing to all the other components. And these I'm just going to rename 1, 2, 3, 4 respectively. And this corresponds to our quadrant location. So this just makes it very easy to find things and fix them in the future if we need. And now that we finish that, we can hide all those, hide our joints right there. And now let's apply our material. So our bearing housing, we can right click, physical material, and this is 6061, drag and drop, perfect. Our screws here are already set to steel, but we can change the appearance. Let's press A for that. And then we can just go here to black, because these are black oxide screws. So I can drag and drop. You see, if I drag and drop to 1, it will actually change all of them. Perfect. Now let's go like this. Let's hide everything. Let's hide those screws and our bearing housing. And we've got our 2 bearings. And remember, these are stainless steel. So let's go over here. I'm going to pick both of those, right click, physical material, metal, and let's find stainless steel. I'm just going to go generic stainless steel over here. I'll drag and drop over here so that it applies to all the bodies. But of course, these seals are actually made of plastic. So let's go back and find the right kind of plastic. Now, I don't actually know what kind of plastic these are supposed to be. So if there are any engineers out there and you know what kind of plastic the seals are supposed to be, let us know in the comments below. But what I'm going to do is I can just drag and drop right on top of those and it will change them to the respective material. Let's make the rest visible. And I'm also going to change the appearance of this to our blue anodized rough color. That is looking really good. So now what do we need to do? Well, let's make the crankshaft assembly visible. And we can go to our top level component over here so that both of them we can work with. And let's join the shaft to our bearing housing. So let's do that. We're going to join, first of all, this point of reference. It's the center of that face. And we will connect it to our bearing right there. This is looking great. You can see what faces are actually connected with each other. We can check this one out too. You can see that this shaft is extended just a little bit past our bearing housing, which means that anything that's connected to here, like the prop driver and split ring, will not interfere with our bearing or this face. So that is looking perfect. Now, the one thing that we're going to change is our motion. Let's go there and make it revolute. And this will give us a preview of what's happening here. That looks great. Now that that is assembled, we can make the crankcase assembly visible. And we are going to join the center of this. And I would like to pick this face right here. And instead of picking the center of the face, I'm going to pick the center of the bore, which is this little plus sign right there. Again, the square is the center of the entire face. And this is the center of the bore. So let's pick that. And then the corresponding one on this face. Again, we can pick that. And this, we don't want it to be revolute. We want to make that rigid. And let's go OK. And now we've got everything set up. So let's go back to joints and make sure we do some housekeeping here. So this we're going to call our crankshaft assembly to our bearing housing assembly. And then rigid 3 is going to be our bearing housing assembly to our crankcase. Perfect. Let's hide those both right there. We can make the cylinder jacket visible. And now this kind of gives us an indication of what we are working with. So you see this pin right here? The con rod is going to be connected to that. The follower shaft is going to be connected to this, to all the cams over here, which will drive the poppets up here and make our engine work. So just before we get to the next part, we'd just like to say if you've benefited at all from this tutorial, if you've learned something new, we'd love to hear from you. Please put it in the comment section below. If you love our channel, please consider subscribing and hitting that notification bell. And if you really love us and you want to support us, please consider becoming a YouTube or Patreon member. Patreon has a ton of extra goodies. You can access these beginners tutorials as well, among many other things. So hope you check it out. So this is looking great. Again, at this point, what we could do is go back to our analysis, This has a section AA. We're going to add another analysis right now. So let's go there to inspect and go section analysis. And let's just pick this YZ plane. So let's pick that and go all the way through. And we can even call this analysis our section YZ plane. Very good. And now we can grab that pin and we can add some motion. You can see that everything is updating as we change this motion. So if you're at this point, that looks great. Let's just hide that analysis right now and we can go back to our home position. Let's minimize everything. So we hope that you've benefited from this tutorial. Looking forward to seeing you at the next one where we're going to discuss the back plate. We've got some oil light bushings. We've got some stock bearings as well that we're going to add. And maybe we'll even get to the piston and liner. I'm not quite sure. Thank you for joining in and hope to see you at the next tutorial with the Learn It channel.